Let's look at the execution of scaling. Therefore, we use the crane example again. The load pin has to be load-free, and we have to trigger tear. The experimental setup and the output signal now supply 0 volt. In the following step, the desired nominal load will be upset. Scale has trigger for 5 seconds. Then the output adjusts to 10 volt. This video explains the scale function of load pins. Requirements for the use of the scale function is a load pin with integrated electronic. Furthermore, the scale line must be drawn out. This can be seen in the wiring code, which is located on the last page of the datasheet. Purpose of the scale function is the precise adjustment of the output. This will be illustrated by the following example of a crane. A load pin has to be mounted in a pulley. The load pin has an output of 10 volt at 200 kN. This setting was made in the laboratory. If you mount a load pin, there can be a slightly different output caused by changing geometries in the pulley or even by the storage. Also, changed angles and deadlocks cannot always be adjusted exactly in the laboratory. Now we want to consider that the output is 9 volt instead of 10 volt at 200 kN. Please note that this is an exaggerated representation. Goal of scaling is to adjust the signal at 200 kN in the installed state to 10 volt. Let's look at how the scale function is triggered. For that, we will look at the load pin at the electrical diagram. The three important conductions are supply, ground, and scale. The scale line should be permanently connected to the ground line, so there will be no switching errors and incorrect scaling of the load pin. Now let's look at the sequence of scaling. We also use the crane example again. The load pin has to be load-free and we have to trigger tear. The setting provides the output of 0 volt. In the following step, the desired nominal load is applied. The scale line has to be connected for 5 seconds. After that, the output fits on 10 volt. Let's look at the flow chart of scaling. The sequence diagrams are shown in the loaded condition. At the top, we see the electrical state of the scale function. If it is set to 0, the scale line is on ground. If it is 1, the scale line is on supply. In the lower diagram it can be seen that the desired scaling of 9 volt to 10 volt at 200 kN by falling edge of the scale wire is displayed. Now we summarize the scale function. In general, it can be said that the scale function will change the characteristic of the output signal. The bottom line in this graph shows the original scaling of the load pin. It supplied 9-volt output at 200 kN. The new scale provides 10 volt at 200 kN load.